So I think, you know, it's gonna be so beautiful. So imagine these gears, like, wow, I would like literally zoom in on the goosebumps. Hey everyone, I think these are the first parts of the Marble Machine 3. I actually think that this steel hub will go on a world tour and play live music on a stage for you one day. So yeah, things are getting real. The steel hub here is going to be right here in the center of this huge plywood gear eventually. And I think the design of these parts shows that I've learned a lot of lessons. I think these parts will perform so much better than my earlier machines did. I mean, the first Marble Machine and Marble Machine X beat me up really badly. I spent 2 years preparing my comeback, trying to become a stronger designer. I think I'm ready for taking on the Marble Machine 3. This is the first part made ever for the Marble Machine 3. I think what's in this box is actually going to go on a world tour one day. Yes! This is a hub machined from a solid block of metal, and it's made by Alex from Brem Precision, and he also included the first ever metal ships machined for the Marble Machine 3. Okay, but why is this hub better than before? I think you could put it like this: there's very few completely unique problems. The Marble Machine itself, well, that's a unique problem, but rotating a wheel around a shaft, that is not a unique problem. There's a lot of other engineers who have had this problem through the history of engineering, and they have solved it. These solutions are tried and tested. And on the first machine, I took no interest in the existing solution. I just went to my hardware store and got a threaded rod that I used for all the axles on all the wheels on the first machine. A threaded rod is not straight like a precision ground shaft, which means that the wheels will always be wobbly. On my second machine, I learned that you could use a real shaft, but then I missed how to put the bearings onto the shaft, and I ended up in a horrible situation where I needed to whack the shaft into the bearings for like days. Even though it looks on the Marble Machine X that wheels are turning really nicely, we couldn't really trust them for a world tour, because when I was whacking the shaft like that, I might have destroyed the bearings, and it also made it impossible to repair and replace anything on the Marble Machine X with 10,000 parts. It didn't have a solid design foundation. I think I've learned so much about what is a solid design foundation. For example, off-the-shelf parts. I didn't know they existed before, but I found them and they're great. Off-the-shelf parts are tried and tested solutions perfected by smart engineers over a long period of time, and they come with documentation that tells us what they can and what they can't do. And if we install the parts correctly, we can actually know how these parts will perform over a long time. We're building a secure foundation for the world tour. These tapered bushings from SKF is a really cool way to put anything on a shaft. Put the bushing on the shaft, the bushing goes into the hub. On the other side here, we're gonna mount with a second bushing. But how does a tapered bushing work? Let me show you. On the Marble Machine X, I used shafts with a keyway and then a gear with a corresponding keyway, and to lock them together, a key like this. So when the shaft is rotating, the gear is rotationally locked together with the shaft. With a tapered bushing, you can have a shaft without a key. And here's the tapered bushing. The inner ring of the bushing can shrink and hug the shaft like this. And the outer ring can expand and hug the gear from the inside. But how does that work? Well, the tapered bushing have these super cool tapers right here. When you push these two set screws to the right in your image, you push on this part, and that rides on these tapers and expands this way and shrinks this way. So it pushes this part into the shaft and it pushes this part into the gear and locks everything. So watch what happens when we put the screws in. Everything expands in two directions. If I open this tapered bushing, you can see that inside we have these ridges. It's the same as the ridges over here. And on the inside of this ring, we also have ridges, which is these tapered ridges here. So this expands and this one shrinks. Great, so there's set screws here. And now I'm just going to tighten them with my Allen wrench and we're done. No. Normally I would take these instructions from SKF and just throw them over my shoulder, but we're not going to do that anymore. We're growing up and we're actually going to read all these mounting instructions and mount this properly. It's actually a pretty interesting process. Let's prepare the hub for proper mounting of the bushings. The first step is to make sure that all contact surfaces are clean and free from oil, and I'm using alcohol here to completely clean and degrease the parts. I'm protecting all interfaces with painter's tape, and I'm protecting all the other surfaces from rust with clear lacquer. When lacquer has dried, I'm removing the painter's tape from the bushing interfaces, and now we can move on to step 2. Perfect. These bushings are really cool. They consist of 3 individual parts. So here's the inner sleeve. When it's on the shaft like this, it can hug the shaft really tightly. Outer sleeve, you can slot them together, and that goes on top here. We have to move the slot away from the set screw. So I'm putting the slot in between these 2 set screws, and this is ready to mount. That looks legit. It says in here exactly how hard I should tighten these screws, but how do I do that with this tool? I don't. Today I'm growing up. I'm taking a detour on my way to the studio to buy some torque wrenches. 4 to 24 Newton meters and another one 20 to 110. Trying my best to not buy everything. I got torque wrenches now. This marks the end of me just tightening bolts and screws willy-nilly. I'm actually going to use Newton meter to tighten these screws, as you should per the instructions, right? On the SH30, we want 18 Newton meters of torque. So now the wood is keeping this from rotating, and let's see if we can get a click on 13 Newton meters. There, that's 13. 13. Okay, so let's set this to the final torque, 18. That's 18. 18. So satisfying. Like, a lot of stuff in engineering is not guesswork, or it was guesswork until someone else figured it out. 18. Retightening each screw twice. We also have the back side. So on this hub we're using 2 tapered bushings, and that's called double mounting, and that's something SKF is addressing in their manual. The second tapered bushing will only add 70% of the torque. 1. Why do I think this is so much fun? Because I'm learning, and it's fun to learn, I guess. I guess that's it. And also I want to prove everyone wrong. Less people than ever believe in this project now. And I'm going to bed every night with like, I'm gonna prove you wrong. I'm gonna prove everyone wrong. Not only prove wrong, it's going to be more beautiful and better music than you think. Alright. Can we really trust this solution? Isn't there a risk that the friction fit will slide? SKF says we can trust it, but I want to verify. I'm gonna build a test rig to apply max torque to this solution to see if it really holds up. So I'm going to put a lever here and put my body weight here to turn the gear. Then I need to lock the shaft. This shaft can't move, so it's locked to the table here. And if I put my body weight here and the gear actually rotates, then the taper bushing has failed. That's what we're going to try. I need to lock the shaft to the wooden board here somehow. I think I need to grind a flat spot with the angle grinder to be able to lock the shaft. I'm adding 2 blocks to keep the shaft from moving sideways. Now I need something to push down on this flat spot, so M12 bolt through wooden block. Getting quite a lot of pressure, I think. It's holding the weight of the lever so far. All right. We're ready to try this cannon. It looks like a cannon. Okay, I thought we were ready for the test, but I realized that the whole thing is just going to fall over, so I need to extend the base a bit. Okay, so I'm gonna do tests at 25, 50, 75 and 100 centimeters. I'm weighing 80 kilo, which means that at 25 centimeters I have 196 Newton meter. The bushings are rated for 900, which would be 114 centimeters. So all the way here is the rated line. I don't think my test rig will be able to do that. So when I put my weight on the lever, we will measure if this friction joint can take my weight. All right. I don't think the rig is going to take this. Okay, 25 centimeters. Well done, Martin. Well done. Let's see if... Oh, so stupid. So the problem now with the test rig is that I haven't managed to lock the shaft. The shaft is still turning, so then the lever will turn as well. I need to lock the shaft harder. Oh no, I'm smoking my drill. Yeah, it just rips the wood apart. I talked to my studio neighbor Ludwig about this and he came up with a new idea. So I'm gonna give this a second go. I really wanna try the bushings. Okay, there I got it. Nice. I'm machining again. It feels like it's for real now. Yes. Okay. I think we have keyed this shaft now. I went ahead and made the second hole as well. Okay, let's get this on the test rig and see if this will work. Click. Okay, it feels different now. So I'm at 0 Newton meters. I'm gonna walk to 25 centimeters. And it's holding for 196 Newton meters. So I'm walking out to 400 Newton meters. I'm at 400 Newton meters, 50 centimeters. And it's holding me. 600 Newton meters at 75 centimeters. I hear the wood creaking. And it's rated over here. But my test rig isn't. I'm gonna strengthen this test rig tomorrow. It's a new day, new energy. Obviously, the wood here is the wrong material to build this test rig for. We need something much stronger and reliable. We need birch plywood. So I've been cutting up these plywood parts from the gear production. These were leftovers from the cutting out of the spokes. I'm putting them together, and this time I'm going to have wood under and above the axis so the bolt will not be able to climb up. This looks much better. So let's see if plywood can do the trick. Okay, so now the bolts are supported also above the shaft by stronger wood. All right. 25 Newton meters. I'm walking to 50 centimeters with 80 kilos. And it feels kind of sturdy. So 400 Newton meters, half the rating. Come on now, test rig. Oh, it's holding me. Yes. Yes. We're at 75, 600 Newton meters. Okay, but this feels increasingly more crazy to walk out. Can we do 1 meter? No, that's the sound of the. I'm at 1 meter. Is that the lever? If I put my weight on the right foot, we're at the rated. Sounds like the lever is going to. Yes, we did the rated. The lever doesn't really want to play. No switch in the SKF bushings. I'm gonna. Yes, we're doing it. We did it. We did 900 Newton meters. The lever is broken. But, whew, finally. Okay, so you see the line here on the bushing, and here's the line on the hub. Perfect. Hard to see for you, but the line is perfect on the bushing. Okay, well done SKF, you did it. It works. It looks like I have done my homework, I've read the instructions, and it's delivering. But why are we not using a keyway? Well, a keyway is a classic method that we used a lot on the Marble Machine X to lock something rotationally on a shaft. And the key is perfect to keep the rotational lock, but the key doesn't stop the gear from wobble from side to side like this. The tapered bushing though, it locks both in the rotational direction and in this side to side direction. It does two jobs at the same time and removes the need for machining these keyways. I do admit it feels scary to not have that locking fit that the keyway provides, but SKF wouldn't have this product if it didn't work. I've also learned to ask professional experts for help. I don't need to do everything myself, and this steel hub is made by an expert, Alex Brem from Brem Precision. I'm here with Alex from Brem Precision, who made this part, and I wonder why machine this part from one big lump of metal instead of making a disc and welding it onto a tube? Why?
Machine it in one piece is easier, but it's also better. You have less stress at the weld, so it won't break over time. I think that's the big reason.
Isn't it expensive in time for machining all this material away and for the tools to become worn out and stuff? Is that not expensive?
No, the tools, they hold up, but yeah, it takes a lot of time. Welders are expensive. And after welding, you also have to machine.
How much material in kilo did you remove from this piece?
45 kilos.
45 kilo of metal you removed?
Yep. Yeah.
Was there any issues in making this piece? Did you have any problems?
No, not really.
Okay. Good.
Big heavy stuff is what I do, so...
If people would like to work with you or have you machine parts for them, how can they contact you?
They can always send me an email.
I just want to say a huge thank you for helping me with the Marble Machine 3 and doing such an amazing job with the part. Thank you so much.
Yeah, no problem.
I also had great help with this design through the Marble Machine Engineering Discord server in the Metal Hub channel. We discussed a lot if it would be easier to just weld a disc to a smaller pipe or to remove this much material from one block of metal. And I think Kilgore put it perfect. Yeah, a weld makes for really uneven hardness and extra work just to save on a pretty cheap material. It's a false economy. For the Marble Machine 3, I'm going to invite you, the audience, to collaborate a lot with me on a lot of the designs. I also got help with the drawings. I uploaded my first version, got feedback and made this second version. And then BMank 2000 came in and posted a great post with a lot of learning for how to make a nice looking drawing. So I'm learning to do a machinist drawing from the audience on the Discord server. It's really fun. And then a while back, I asked if someone had a CNC machine in Stockholm, and oh boy, did they have one. So I have collaborated to make this wheel with Ateljé Örnsberg, which is a high-end custom furniture wood workshop. And Tobias from Ateljé Örnsberg helped me make this wheel. It was an amazing day, and we will cover that in full in an upcoming video. So this will become a double helical gear. Currently, it has no gear teeth because we're gonna machine that in the next operation. Talking about collaborations, I moved to this new place. So let's go to the second camera. Here's my view. So this room is my room. It's called Studio 3, and I'm in a live streaming studio complex in smack dab middle of the city of Stockholm. And this gear, I didn't build it. It was a Fallout live streaming set. And we're actually going to take all this down this Sunday and make this into a bigger black box for me. And then we have Studio 2 here, which is a green screen room where I have stored some stuff. And then out here we have Studio 1. So this, as you can see, is pretty cool. I love this place. You have like cameras on rails that moves by themselves. Stuff like that. And of course, Marble Machine 3 vanity wall. So yeah, this is a really cool space. I'm not working so much in here, but Ludwig and his colleagues are working in this studio. And talking about Ludwig, I can see him there in the control room. Here's in the control room, and there he is. Hey, Ludwig.
Welcome to the lair.
Ludwig is a broadcast specialist, and we're planning to do some really nice live streams together from this control room, so all of you guys can help me with the design of Marble Machine 3. We met through YouTube, actually.
Yeah, I mean, I saw the video where you were angle grinding in the shower, and I thought, you should be here. We have the space, we have the room, so that's yeah. So I reached out and the rest is history.
I'm so happy to be here. Ludwig is also a super hacker, and I'm not so good at coding. For example, like he opens the door through one of the 1 million Stream Decks he's using. So you guys are sleeping on your Stream Deck game compared to Ludwig. So I'm very happy to be here with you, Ludwig. Thank you so much. So yeah, this is the control room, and then we have some other spaces as well. Mortal Kombat arcade machine, of course. These are kind of my favorite space. It's the warehouse. In here, we're actually going to build a CNC space. So this is where the CNC machine is going to be, and we're going to enclose it and make it into a woodworking section. And this is where the plywood parts are going to be, so all the plywood sheets and stuff. And yeah, so this is amazing. And Ludwig is also like a 3D printer enthusiast. So I'm gonna show you. And this was the moment when I realized I was gonna feel at home out here, because Ludwig's work table looks like mine. That's a perfect work table, according to me. So here's my friends, Aron, hi.
Hello.
Linda. Hello. And Trixie. It's so fun that I have company here, that I'm not alone. And this is the last space. In here I'm gonna do all painting and like all dirty work, like grinding and stuff like that. So we're gonna fix this place up. So all things that smells is in here. As you can tell, I have great opportunities here in the middle of Stockholm, and I just want to thank everyone who's backing Wintergatan through Patreon and YouTube memberships. You're really making all this possible and giving me this 3rd times the charm chance to fix the Marble Machine 3. In kind of 10 days, my moving truck is coming here. I haven't moved in yet here. So I made the first videos here before moving in. So in 10 days, I'll get all my music studio equipment here and all my machines and stuff. And then it's go time. I will clean this place up. Having like a clean work environment is another thing that I haven't learned yet. And I think I need to really become better at that to make the work environment clean, to make a clean result. So anyway, you can tell why I'm excited to be working in this place and building Marble Machine 3 and making great videos for you. Let's make this happen. World tour. The boy who cried world tour. Thanks for being with me on this amazing journey. I think I'm going to make it actually.